Well, here's another quick and greasy video for you. I'm trying to make some custom gate latch hardware because I'm too cheap to spend $25. Actually, I think I can even get it for 20 bucks off of Amazon from China for a two-way gate latch system. So there's really, as far as I can tell, only like two systems out there for like a sort of independent bar gate latch system. There's one that uses rings, and then one like you see with your standard tube metal cattle gates that's got a bar that goes into two fingers that it ramps into, and you can pull either up from either side in order to open the gate. And then there's one that has a set of rings that operates in the same way, and it has two rings like this, and you slide it in and it goes in between the two rings. It sort of goes just above their center, and if you just pick up one side of the ring, or I don't know exactly how it works, but if you move the either ring up, you can open the gate and move it through. So instead of just buying one of those and being done with it, I'm gonna try and save $5 and spend 4 hours of my time making a custom latch, just because I had an idea for a different system, and wanted to see if it would work. Basically, what I'm doing is I'm making a ramp with a drop in the middle, like this, a sort of triangle with a hole in the top. And I'm going to have a bar on a pivot that's spring loaded so that when I swing it, it goes up the ramp, falls into the drop, and then latches the gate. And then if you want to open the gate, you move the bar down and you open the gate in either direction. So you close it from either way and it ramps up, falls in, etc., etc. You'll see when I'm done with it. But first step is I'm trying to make that latch plate. And what I've got here is a piece of 3-inch hot rolled steel, just regular old flat bar, 1/8 thick. And I've just cut this to 4 inches, and I'm going to stick this in the vise. I'm going to try and bend it in thirds. I'm going to try and bend it basically into a Z pattern at 90-degree angles in thirds, and I have no idea if that's going to work or not. But we're going to give it the old college try, and hopefully it does. We shall see, and I'm not going to bother showing you any dimensions or anything like that until I get to the point where I'm actually cutting on something. But just know that this is 3x4. If you have a large sheet of steel, you're probably better off making it like 4x3 or something like that, so you have a little bit of extra meat to play with. But we're doing this because I have a piece of 3-inch flat stock, and I'm not buying another one. Well, here's what I was able to bend with the tools on hand, which is a big pair of pliers and some hammers and a table vise. So I think I did all right, all things considered, although it is nowhere near perfect. And now the next step is we're going to cut a 5/8 inch wide slot in here, right here in the center on one side. Just pick the straightest looking side, because I've got this side that's all sorts of bent. So I'm picking the straight side, and just right here dead in the center, I'm going to cut a 5/8 of an inch wide slot, and that can be anywhere from 5/8 of an inch deep to 3/8 of an inch deep. I think I'm going to aim for 1/2 an inch and settle for 3/8. Hardest part's going to be cutting the bottom. If you got a Dremel, go for it. If you got a tiny angle grinder, go for it. Another solution is to just cut a V, which I think is probably what I'm going to do. Is just measure out something probably 3/4 of an inch wide that goes down like an inch or something like that, and just cut a little V in here so that the plan is to have a 1/2 inch rod sit in the middle of that. So I'm going to get cutting that out, and then the next step after that is I'm going to cut basically from the tip of either side to that all the way down to right here at the very bottom of this. So just above that. So it's about, his plan was a 1-inch drop. I think we're probably closer to a 7/8 drop. So it'll be from just about here to just about there, roughly. And that doesn't need to be precise. The wider you make this, the more shallow you can make that cut, which will be better. But anything will do, I think. I don't know. I haven't tried this. Alright, I don't know how well you can make that out, but I've just very roughly scribed that in there with Sharpie, so not really scribing, but that's basically what I'm going for. It's sort of like a widened V. And I'm just going to hack on that with the reciprocating saw and do some of the finished work with the hacksaw, and we'll see how it comes out. Alright, there's my chunks, and there's my latch plate. and that actually came out looking a lot better than expected. Generally, when I try and work with this stuff and the reciprocating saw, it's a nightmare, but for whatever reason, it didn't fight me tonight. So the next step is we're going to drill three 30-second or three 3/16 inch holes through the bottom of this, one in the center and one inch apart on either side, and that's so that we have 3-inch spacing so that we can put deck screws through this. Probably need to go a little bit bigger than 3/16 of an inch, but I don't care. I'm just going to strip the deck screws slightly when I run them through here. So I'm going to put one in the center and maybe 3/4 of an inch. I'm going to have this mounted to a 4x4, so I think having a total of 3-inch spacing is probably not ideal. So I think I'm going to space them 3/4 of an inch apart, because this is 4 inches wide. 4x4 would be this big, and this would be 3-inch spacing, and that only leaves me about 1/8 of an inch on either side, or 1/4 of an inch on either side. Well, plus the size of the hole, so that's not ideal. So I'm going to do 3/4 inch spacing. So I'm going to shut up and do that. Anyway, what I meant to say before I started rambling incoherently is that I'm going to do 1-inch spacing, because that's a total of 2 inches, not 3 inches. I don't know what the hell I was on about. I thought about this in depth earlier when I was not drinking rum, and I already got it sorted out. So I just need to, listen to what sober me told me to do. Although that's not always the best decision. But anyway, so we're doing 1-inch spacing because that's a total of 2 inches, not 3 inches. And that works out pretty good. That leaves us exactly 3/4 of an inch either side on the 4x4. So that'll work out just fine. And I may try and countersink these. I don't think I have a countersink bit that'll work for metal. So probably not. So we'll just have the deck screws sticking out the top of this. And yeah, I'm going to get to drilling real quick and probably burn up this cheapo bit I found. Alright, there we go. And a number 9 deck screw will just slide right on in. However, I believe a number 10, at least I think this is number 10, it might be a 12, jams up a little bit. But you run that through with an impact gun, especially one of these that's, serrated and self-tapping. It'll cut its way through. Just make it hold better. So yeah, I'm going to go take this over to the belt sander, clean up all these burrs, smooth out this edge, maybe get on it with a hand file a little bit. And I think that's the latch plate pretty much done once I, put some better geometry on it. We're going to try and smooth this edge out, make it, not, sharp and haggard like that. Clean up these tips a little bit, take the points off, and, just take all that nast off of the back. And I think that's about done. And then we're on to making the, latch bar / handle, I don't know what you want to call it. Which should be easy as pie, except it'll be hard to manufacture, but it's very easy in concept. Basically making a tire iron with basically a tire iron. I wonder if I have a tire iron I can show you. I got an emergency jack, but I don't think it's got the correct kind of tire iron on it. But anyway, if you get a tire iron, they usually have a bend in them like that, and then a little hole in the middle of them. So that if you have an emergency scissor jack like that, you can stick it on the end of it and use it like a wrench. We're basically going to make one of those, except with a T on one end and at a 1/2-inch rod, so that we have a little pivot like this that goes like that, and my thumb would be the handle, and there would be one sticking out either side like that, so that you can pivot it up like that around my knuckles with the handles, and we'll have a little spring connected from right here at my first knuckle up to the post, so that it naturally wants to sit like this, so that when you swing it in, it'll slap in like that, stay latched, and then if you want to open it, you hit the handles like that and it'll open. You'll see it. You'll see when we're done, or maybe future me will edit in the final product at the very beginning, so you have a rough idea. We'll see. And there it is, nice and clean. I didn't even have to use the hand file. I just used the old belt sander over there. And yeah, I may decide to square this up in the middle here, at least down at the bottom, just because we'll fit it in the field. But it feels like whenever the rod falls in here, that if you push hard enough, it can open, and that may be a good thing. We'll see. We'll see how much force it takes. I really only need this in my application to keep deer out. That's all I'm using it for. Is I've just got a gate swing gate that is always open, never going to be locked. I just need it to latch and keep deer out. That's all it's doing for me. So I think this strike plate here, latch plate, whatever you want to call it, is done. I think that's pretty good. That's better than I expected. I think it only took me like maybe 45 minutes to do. So yeah, I've got to go buy materials, but we'll start working on the whole handle assembly after this. Hey, look at that. I found 4 foot of grounding rod. So this is about 1/2 inch diameter. I think it's like actually 9/16. It's something close, doesn't matter. It's at least 1/2 inch, so I'm going to cut this off at 1 foot. I think that should be plenty long enough for what I need. I may trim it to length, but 1/2 inch is going to work perfectly for the time being. So I'm a hack on that. Alright, so what I've done is I've just taken the belt sander, and just to make my life a little bit easier, this isn't necessary, but just because it makes my life easier, I ground a semi-flat spot here at 4.5 inches and then one about 3/4 of an inch from the end. And that's because we're going to be drilling through this, and the goal is to put about a little bigger than a 1/4 inch hole on this end, maybe a 5/16 hole right here through the middle of it, which is going to be a bit sketchy. And over here, I think we're going to do a 7/32 hole in here, whatever size needs to be done to tap a 1/4 inch hole. Or if you really want to, you can just make it exactly a 1/4 of an inch or 5/16, and then you can run nuts on either side and then lock everything down. Then you don't have to tap it. But I'm going to try and tap it first, and if I screw it up, then I'm just going to bore it out, and then we won't tap it. But that's the current plan, is to drill a hole through here and through here, that a piece of 1/4 inch bolt, I believe these are 1/4 inch, I think, maybe? Something, yeah, I think these are 1/4 inch, so the 1/4 inch bolt can run right through the middle of that. That's the plan, at least. So we're going to get to that, and catch you on the flip side. Well, I may be dumb, but I'm not so dumb that I don't recognize when I need to be using the drill press, and this is one of those occasions. I just never use this thing because it doesn't have a lot of throw to it. I don't have a transverse vise block because one of those is worth as much as the drill press, and I just haven't bought one, so I can't precision line things up. The chuck on this is broken. Ignore the fact that there is literally a brand new one sitting in the box right there that I just, haven't opened because I was able to fix the chuck on this by just putting it back together broken, and it worked. And yeah, but I'm going to just flip this on and drill a 9/32 hole straight through the middle of this grounding rod and hope for the best. And there we go. Now time to do the back one. Oh, fun. Alright, I think that one's done too. I drilled that one a 7/32 so I can tap it for 1/4 inch, and I drilled the front one up here 9/32 so that I can slide 1/4 inch straight through. So let me test that real quick. This is 1/4 inch carriage bolt. So, perfect. And yeah, she ain't going in. Good. So, I'll get to tapping that real quick. I think I might actually try and do that in the vise. In the drill press, because I've never tried that before, and everyone always tells me that's how you do that, but I have a 3-way chuck and 4-way taps. So, not sure if that's going to work. But we may try and do that just so I can keep everything super duper straight. And then we'll finish up that by hand. And then it's just a matter of me buying parts. But I think I can work something up to demonstrate to y'all real quick. Alright, we got that all chucked up. And I'm going to see if we can do this one-handed, never having done it before. So let's see if I snap a tap in half, because that would be fun. Was not fast enough, I don't think. Well, let me try that again, but with both hands. Alright, well, I didn't try again. I just, it was set in there okay, so I just spun it a couple times by hand and then took it out of the drill press and finished it up by hand. And, yeah, she's started for 1/4 inch now. She's a little bit loose, but that's all right. This was entirely optional. You could have also drilled this out as a quarter inch or 9/32, and it wouldn't have mattered. My plan is to stick a quarter inch bolt through here, and this is going to be the pivot. And this end right here is what is going to hit the strike plate and latch in. And I've got this random spring I found, which will be connected somewhere in here by some shape or form, maybe a hose clamp. I don't really know. And then this will be hooked up here to the frame where that pivot is mounted, and it'll be putting constant downward pressure on that tip, upward pressure on this. And then over here, I'm going to run some quarter inch all thread all the way through, lopsided to one side, make one side about 2 inches longer than the other. And I'm going to put a handle on here so that people can grab this and pull down. I may do a sort of loop handle like that so that people can pull down like that. It'll pivot right here. This will be sitting right here. This thing will pivot. This will come up. They can move it, and they'll let it go, and it'll sit, and then it'll slide in like that whenever they shut it. It'll be hunky-dory, fancy. Work perfectly fine for first try. I haven't tested any of this, so I have absolutely no idea if it's going to work or not. But we're going to give it a shot, and yeah. So I guess I am going to go buy some all thread, and I'll see you whenever I work out the rest of this. Alright, I've been to the hardware store, and we got ourselves a bunch of goodies now. I bought myself a 3-foot piece of quarter inch all thread. This is coarse threaded, and really all I'm going to need is 9 inches of it, but I tear through quarter inch bolts like you wouldn't believe. So I just bought 3 foot of it. I probably should have bought 6 foot, but anyway, all I'm using is 9 inches right here, and that's going to be 3 inches on either side for insertion into a handle, and then an additional 3 inches in the middle for wiggle room. We're only going to really need 1/2 inch, 2 inches in the middle, one for 1.5 inches of 2x4, and another 1/2 inch for the rod. And I'm going to give myself a 1/2 inch on either side just for an air gap, just to probably because I have nuts and I need the nuts inside of there to hold the thing in place. You could theoretically hold it in place with the handles, but I'm going to use nuts just because I want to be fancy. And I probably don't need to use lock nuts like this, and I think I've got some quarter inch nuts lying around. But I may use lock nuts just to be fancy. I gotta go shut that dog up. What are you chortling about? Huh? That's what I thought. Anyway, before I was so rudely interrupted, we're going to lock it down with nuts, and you got three on either end for the handle and 3 in the middle. Really only going to need 2 of it. Probably going to need quarter inch on either side for the nuts, but I'm just giving myself wiggle room. Then over here, I have what I believe is a 3 inch by 1/4 inch hex bolt, and as you see like that, we'll have 1.5 inches inside the wood plus a washer, which will take up a 1/4 inch or 1/8 of an inch, another 1/8 of an inch over here for another washer, and then we'll have the rod inside of there, and then another washer, and then a lock nut, and it should just barely clearance. And if it doesn't, we'll take a Forstner bit and put a little indent on one side for the hex head and make it fit. And I got a hose clamp, just sort of as a stopgap for testing spring tension. I'm going to stick that on this rod over here somewhere, and I need to do that before I bolt everything down. And yeah, just some lock nuts and some washers. Probably don't need lock nuts. I need at least 1 lock nut, but probably not for everything. And yeah, I'm going to get to assembling this mechanism, and I'll show you when I have it built, because it'll be a lot easier to understand, so I don't know why I just spent all that time rambling. So you're in for a treat. I'm using the drill press twice in one project. So this is like a 1.25 inch dowel. I have no idea what it's made from. It's clearly some type of pine, but as you can see there, it has a very tight grain. I'm thinking this is some old growth heart pine, because it has a glorious smell to it, and it's got that extremely tight grain, and I got no idea where my dad got this. My neighborhood used to be built, or was built, in a longleaf pine savanna, and back in the day, my dad was able to get a lot of pine, like this stuff right here, which was heartwood longleaf, or at least heartwood loblolly for the most part. So I've There's a lot of scrap lumber lying around this garage that I am definitely wasting because I should not be using something this nice on something this trashy. But we're going to do it anyway because why not? Alright, we got this basically centered, so let's watch it wander all over the place. And I'm just going to do this for the throw of the drill press. And then we'll do the other one. And then we'll pull this bit out and we'll finish the rest of it by hand. And that is definitely not centered, but it's not going to matter. Alright, there we go. We just finished them with the hand drill. I drilled these to 3/16 of an inch, by the way. And just look at the grain on that. That is, like, look at that. That is extremely tight. This is a fairly soft wood, but it's very red, very fragrant. It has kept for forever. This has to be like heartwood longleaf. It can't be anything else. Loblollies didn't get that old. It was not that common here on the coast. It was mostly planted, but this is good wood. I put some of this dell to good use on a different project, and I did not realize how good it was when I used it, and then I cleaned it up and was like, oh damn, after the fact. But yeah. I'm going to try and save these handles and use them for the final product. And I think they'll do great because they're going to be outdoors in the elements. And I think heartwood old growth pine should do a lot better than, standard non-treated pine, although treated would do better. It'll do a lot better than poplar, I'll say that much, or maple. So anyway, the plan is I'm going to take this 1/8 inch bolt just to make my life easier, and I'm going to run this down into each of these about 3 inches. I drilled both of these to exactly, a little under 3 inches in length. And we're going to seat each one of these 3 inches deep on either side of this rod. And you can see there I ran the nuts down and I just counter torqued them on either side so they locked in place. And we're going to try and run these down to about 1/4 of an inch, 3/8 of an inch above, or 1/4 to 3/8 of an inch above the nut on this side, and about this far above the nut on that side, about 1 3/4. And yeah, I'm gonna get to it. Alright, do you fellas understand what I'm trying to go for here now? I've got everything together, and as you can see here, spring is here, it's attached by a hose clamp to this rod, these handles are on here, this bolt runs right through there, and it's got 2 washers on either side to act as thrust washers, or thrust bearings, sort of. Back here, I've just got the double nutted because I don't want to mess up one of the lock nuts yet. And the spring's just hooked up here to a wood screw for now, and that may be permanent. I'll have to put a full loop on there and probably put a washer on here just to keep it from coming off. But yeah, and I've got another screw down here just as a bottom stop because I want this to have constant upward pressure. And that's how the latch plate works. You see, I'm going to need to square this up a bit because I can push it off like that. But you see how I want it to close? So imagine that the lock plate is not moving, but that this is moving relative to the lock plate. Goes in like there, falls in that little latch, falls in that valley, holds it in place, and then when you want to open the gate, you do this and drop that on the ground. But you see, hit that like that, picks it up, clears everything. I'm going to need to put another stop up here so that I can have this stop like here rather than here. And this will all be installed on an actual gate. I just did this quick little mock-up with scrap lumber so I could illustrate my point. So this is what I'm trying to do for the gate, and I'm going to take this guy and make this V right here in the middle square. I'm just going to take a hacksaw and just basically from about here down cut, from here down cut, and then do some creative angle grinder work to make that bottom mostly square. It doesn't need to be perfectly square, but what I need is at like 1/4 to nearly 3/8 from the tippity top, this to be a straight wall. I guess 3/8 from the bottom, I need this to be a straight wall, so that when this is in here and you push on it, it hits a flat wall and it doesn't have a ramp like this where it can ride out. And this is sort of nice, if you just want to be able to push the gate and have it open and have it swing back and closed. But if I'm, if I don't want the wind to push this open, or I don't want, like a deer leaning against it to open it, I need to do something about that. So I'm going to square that up. But yeah, this is generally what I'm going for. And once I get the gate installed and all of that in place, I'll show you this actually on the gate functioning. And I may hack another inch off at the end of this so that I can, adjust this gap in here accordingly. I left this kind of long just for that reason. Plus this is a 3-inch piece of wood because this is broken off of a 2x8, I think. So yeah, it should only be sticking out. Actually, that's about perfect. With a full 2x4, it'll be sticking out 2 inches. And I want to leave probably 1/4 to a 1/2 inch at the back of this. So that's probably going to be good, but I might hack another 1/2 inch or so off of it. And we'll figure that out in the field. But yeah, I'm going to square that up. And then I'm going to build the gate, and we're going to install this. And you're going to see whether or not this works or not with me for the first time. So I guess without further ado, let's get to that right now, unless I decide I want to change something about the design between now and then. But until then, so we got an arch for the gate built up. I'm going to put in some extra bracing on the side of it, and we'll be able to hang the gate up here shortly. Well, here's the gate latch. As you can see, it's installed, and it does work. It doesn't work great, but that's because of the spring. I just need to get a stronger one. If I really stretch it up to here, then it works. So it's just a matter of spring strength, and this handle is very easy. So that's all it is. I just need a beefier spring. And I decided to just latch this spring onto this weld wire because it's here. And yeah. Bam. That works pretty dang good. So yeah, reason why I'm doing this is because this is ADA accessible. Well, that's the intent. So anyone can close this. Anyone can open it. Like, that's all it takes, and it goes. And because this is spring loaded, all you have to do is get it up onto this ramp like that, and it'll, like, come on now. As long as you get it that far, it'll launch itself open just a little bit, and you just, the gate opens. And I've got it set up to fold all the way out. And once I move all that crap, I'll be able to put a little latch on it. And when you want to close it, it's just that easy. You just pull it, opens this way, swings out 90 degrees, closes. Yeah, see, I gotta work on that. It needs some new geometry, but it's pretty good. I just probably need to make that wider and maybe a little deeper. And that's all it'll take. I think that's pretty good for now. So there you go. Your custom-made, dirt cheap, 2-way ADA accessible gate latch. All it took was a lot of too much effort. Too much effort. So yeah, that's it. If you like this kind of trash, make sure to like the video. Go down there, comment, tell me how I can make this better, because it probably needs a couple of tweaks. And if you want to see more of this garbage, make sure to subscribe. Till next time, I'm out.